Hey guys, welcome back. Now we know how to write MapReduce programs, and we also executed MapReduce programs in our cluster. Take a look at this output from a MapReduce execution. With this MapReduce execution, we calculated the maximum closing price of each stock symbol in our stocks dataset. Now, how can we find out how many records that our MapReduce program processed? It is very easy to find out. Here is the information. It is right in the output of the program. Our MapReduce job actually processed about 7.4 million records. If you want to find out how many records our reducers processed, here is the information. Similarly, if you want to find out the number of records processed by the combiners, here is the information. We can also find out high-level information about the jobs like the number of map tasks, number of reduced tasks right here. What we are seeing here is called counters. And as you can see, they provide valuable information. Here is file system counters. Here you will see all the counters from the file system with respect to this MapReduce execution, like number of bytes read and written from HDFS, etc. Similarly, you can also find counters from the MapReduce framework, which can provide us valuable information. Counters provide consolidated information about the job. As we know, a single MapReduce job can have hundreds of mappers, and all the tasks in the MapReduce job can be executed across several nodes in our cluster. Counters provide an excellent way to consolidate and provide a unified view of the job from all these tasks that execute on several nodes across the cluster. The counters we see here on the screen are predefined counters in Hadoop, and they come very handy when you would like to analyze the job output, especially when the job failed with issues. Let's say you got a new data set from your market research team, and you were told column number 3 is a numerical value. So you wrote a MapReduce program assuming column 3 is a number, and you're performing numerical calculations with column 3. Now when you execute the program against the dataset, you get errors when your mappers are processing records because column number 3 does not have a numerical value for a lot of records, and you suspect too many records in this dataset might have this issue. So now you have to go back to the market research team who gave you this dataset, informing that X number of records might have this issue, and ask them to provide a dataset correcting the issue. Now, how can you find out how many records have this issue? It is very simple actually. You can write user-defined counters in your MapReduce program. Let's try it out. To illustrate this, let's take our stocks dataset. This MapReduce program will calculate the maximum closing price, but in addition to that, let's say we would like to know the number of records in our stocks dataset with volume greater than or equal to 500,000, and number of records in the stocks dataset with volume lesser than 500,000. So we will define two user-defined counters as an enum. Here we are defining two counters, high_volume and low_volume. Anytime we see a record with volume greater than or equal to 500,000, we get the counter using the context object and increment the value of the high volume counter by 1. Else, we would increment the value of low volume counter by 1. These 5 lines that you see here are the only addition to our maximum closing price MapReduce program. Now let's try to execute this MapReduce program and see how many high volume stock records we have and how many low volume stock records we have in our stocks dataset. To build this project, simply just right click and say run as Maven build. If you're building the project for the very first time, you would have to specify the goals for your Maven build. In that case, just say clean space install. Right now our project is building. So let's wait for the Maven build to complete. Maven has successfully built the project. I've already copied the jar file for our MapReduce program to our cluster under HIRW workshop MapReduce stocks, and I've named it as max close price counters 1.0.jar. We're going to use the stocks dataset from the same input location as before. So before we execute the MapReduce program, let's just delete the output directory. So I'm deleting the output directory from HDFS. Now the output directory is deleted. So let's go ahead and execute the MapReduce job. Let's wait for the MapReduce program to complete, and let's then review the output. The MapReduce program now completed successfully. And as you can see at the very end of the counters, we have two new counters from our maximum closing price mapper. As expected, we see two counters here, high underscore volume and low underscore volume. Now we know from the high underscore volume counter that we have over 2 million records with volume greater than or equal to 500,000. And we have over 5 million records with volume lesser than 500,000 in our stocks data set by looking at the low underscore volume counter. That is it. Using counter is as simple as that. Even though we are incrementing the counter values in the mapper, when we see the job output, we will see a consolidated output from all the mappers. And that is the beauty of counters, and hence they are invaluable. Now, going back to the dataset provided by our market research team and the numerical errors from column number 3 in the dataset. Anytime we see a non-numerical value in column 3, we can simply catch the error, increment the counter denoting invalid records. That is it. When we execute the MapReduce program, we'll get a counter indicating the list of all the invalid records in the dataset. So now you can go back to your market research team with the number of invalid records and ask them to fix the dataset and provide a good dataset to you. So to summarize, in this lesson, we saw predefined counters in Hadoop and the benefit that they offer. Finally, we saw how we can use user-defined counters to record valuable information to get a consolidated view in the output of our MapReduce jobs. With that, let's wrap this lesson. See you in the next lesson.